All right, folks, tonight we're going to be talking about summary queries in chapter 6. And to kind of get a little bit of an underpinning as to what summary queries are, a regular query is one where we select specific information from a table or tables in a database, sometimes based on certain criteria, and sometimes not. Sometimes you're just pulling all the information. A summary query, on the other hand, takes a look at the information and often uses built-in functions that are built into the language to kind of point out certain pieces of information. You can see some of the things that I have highlighted here in the topic list. Like, for example, what was maybe the largest amount or the smallest amount of something, a min or a max, or how many items exist, or if I add these all together, what does it lead out to? Or if I average them all, what is the average? That type of thing. Um, and so a summary query basically is a way to take information in a table and summarize it, right? And this sounds really kind of silly, right? Because it's built right into the name, but it is a really valuable feature. And it's kind of like a precursor to doing reporting, right? And this is a really common task for data people in particular, is to take the vast volumes of information that we have and then find a way to show people what that means. And SQL code has built into it the tools to allow you to do some of that without necessarily needing to drop it into a spreadsheet program to see the results, right? And I think that's really helpful to know. And we're going to look at kind of the nuances of doing some of those things. Some of those actions really begin with what we call aggregate functions. And to give you kind of a little bit of a distinction, is we've already looked at some functions already, right? We kind of used them and didn't really say much about them. But here we're going to take a little bit deeper dive, and an aggregate function is really one that looks at basically a collection of data as opposed to maybe a singular piece of data to get the results of the function. A couple of very, very popular functions in SQL code is the min and the max function. All right, so people in my Python class, boy, does this sound familiar, right? Because we're in Python and we also have min and max functions, which functionally do the exact same thing as these two functions here, which is it looks at a set of data and it finds either the largest or the smallest value in that set of data. Okay, why is that useful? Well, think about it. Like if I was running maybe a query on a database of test scores, it would be helpful for me to know what was the lowest score somebody got and what is the highest score somebody got. Right. And that way I would have a range of what, kind of scores I could expect, for example. So that's why these functions are useful. How do we apply them? All right. Well, one method would be to just simply put it into your select statement and say, I want the minimum value from this particular column, or I want the maximum value from this particular column, right? And then it will just take that value. Is that useful? Well, it depends on what you're doing, right? For example, if I was looking at the prices of homes selling in my neighborhood, and I want to get all hopeful, I might look at the maximum price, right? Or if I want to get discouraged, I might look at the minimum price. Or I can look at the max and the min and then try to make a determination as to why one home sells for $500,000 and the other home sells for 100,000 when they're on the same street. What is the difference, right? But you can't really look at those values unless you can find them. So once again, if you're looking at very large data sets, it's not easy to like scroll through a list and go, aha, that's the smallest one, especially if it's a list of 10,000, right? So these are super powerful in narrowing down what data you're looking at. All right, so they have a couple of little examples here, and I thought I would just bring them up on screen and just give them a try. So they have this this little database here. So we're going to select the minimum price. We're giving it an alias, by the way, from the products table. So we're going to hit the run on it, and it says the smallest price is 250. Now you do have to remember what was on the other screen and whether or not that was correct. So let's go back and look, right? Is the smallest price 250? Well, I guess they're not showing us the smallest price, but we have to take it on fact. Once again, we can also run max price, right, as the largest price. And how do we know? Well, we can look in the table if you guys are curious, right? So that's how we would know. If I was to look manually, I see one here that's pretty large, right? Is it the largest? Well, I don't know, right? But to run the actual statement, and I think I have to reinitiate that. So let's just run that actual statement. And the reason I was showing that is so that you can see, you know, what the data is before we're running the query. But I think what's fascinating about this is I looked at the list really quick, found a different number. I thought it was the biggest one. And of course, my brain was wrong because I looked at it so hastily. And this is exactly the problem of doing this manually. It's not that you couldn't do it manually. You want to do it with the technology. And once again, use the example of what if you have 10,000 items as opposed to 77. That's where it becomes particularly useful. All right, so that's an example of max and min. A couple of other functions that are important ones, and I would say these three, real frankly, are probably the ones that get used the most when writing SQL code. It is important to note, right? So, like, depending on how you want to analyze your data, and I say this predominantly for data analytics students, sometimes you'll do this analysis in other products. You might run a query, you might get a table that contains all the data that you ran your query on, and then you might take that table, save it in a different format, like a comma separated value table or an Excel table, bring that into a spreadsheet program or a visualization program like Tableau or Power BI, and then analyze your information there. And you can find all of these values, the sums, the counts, the averages. But sometimes we don't want people taking our data and then manipulating it and running reports on it. Sometimes we want to control that, right? So for example, if I'm the database administrator and I want to control, who takes a look at the data, right? I might not give them the whole chunk of data on purpose. Okay, so why? Why would I not give somebody all of the data? Well, because the database is so large that it doesn't make sense to give you all the data, because you wouldn't even have tools large enough to manipulate that data. That's one reason. So one reason why we run these functions inside the database is to keep it inside that environment and come up with information that's pertinent. We've used this command before, right? And actually we used the wildcard version where we put an asterisk in the middle just to get a count of the columns. Now, if you guys remember that from a few weeks back, we had an exercise that's like how many things are in the products table? And what most of you did is you just, select star from products, and then you just put the whole thing on the screen and you scroll to the bottom, look at the last column and go, aha, there's 54, right? That is one way to do it, right? Or it says at the bottom, 54 rows, or something like that. However, what if it's significantly larger and you don't know what that count is? Well, here's a way to do it. You can actually select the count of the column name, and then it will tell you how many are in that particular table. Right. You can also set up conditions. So there, so these are the things about these that you can qualify them. Is sometimes you don't want to count everything. Sometimes you only want to count things that have certain conditions that are true. And then that condition is relative to whatever function you're performing. Like, how many men do we have in our customer table? Or how many women do we have in the customer table? Or how many people do we have that live in, I don't know, California, right? You would set up that condition to pull the count. Another one that's very helpful is the average function. So that would require, of course, that whatever column that we're averaging contains numbers. So this wouldn't work, for example, on the date, or would it? That's kind of an interesting thought. And this certainly wouldn't work on a name because it can't really average names Can I? Right. But if I'm averaging sales totals or product values or how many items were ordered, those things I can do math on, so I can take an average. So for example, one thing that you might average is like, what's the average purchase amount per customer? That's a good question, right? Like when people come and purchase something from our company, how much money are they spending on average? Wouldn't that be a great thing to know? It would be. It would be very, very helpful to know. So this basically would look in this format, at least, at everything in a column, would add it all up, come up with the sum, divide by the total number that are there. So somewhere in that, there's a count function built in, and then it gives us the average back. And the more interesting thing is, once again, we can apply a condition to it. So we can qualify it. So what's the average of people that got products shipped, or what is the average of all the males that are purchasing from our website versus all the females? Right, so that very, very handy function. The other one is sum, and that's just simply where we're taking a total. That's also pretty useful. Once again, especially when a condition is applied. So for example, I might have a table that shows all the total sales, but it might have all the total sales for the last 20 years. Is that pertinent? Maybe I'm just looking at the sales totals for every December, like during the Christmas season, or maybe the week leading into Thanksgiving or something weird like that for specific years. You could write condition statements that would grab that, and then you could run the function to kind of qualify it. They have a couple little examples down below. So for example, they have selection from the products table in this database, right? You can see products, supplier ID, category ID, unit, and price. And here they're going to just do a simple select count. So it's a very, very basic statement here to count how many things exist in the product table. This is a pretty easy one to see that we're correct, though. Why? Because we already know how many records are in the products table. So as long as their number matches up with that, it's the column count, right? This is without a condition, though. So we could add a where clause to this, and we could qualify it, and how we do that is really relative to the issue we're trying to solve, by the way. All right, so that's kind of my basic example of doing a count. If you were to do an average, for example, where it's going to average out the prices, of course, we're assuming that this is correct, but otherwise we'd have to go in there, add everything up, divide it by the total number that exists, and this is what we come up with. All right, helpful also, especially if qualified. And then we have the sum that works very much the same way, and I think that's pretty intuitive what it does. All right, so that's what I'm going to say are the basic functions that we're going to be working with for the most part today. There's a couple of others that we're going to tinker with, by the way, and one of those falls into this other area. So I just want to kind of point out a couple of things here. Some of the ones that we looked at just now are like, I think, super important in SQL, and that's why they have their own like pages. But otherwise, if you were looking for a function reference, I think what's pretty fascinating is if you click here on the references here, and you notice that they have functions that are specific to strings. Look at the large list, by the way. We've talked about a few of these. There are ones that are related to mathematics. And I'll just let you look. There's a couple that we've already talked about. And one, real frankly, that we will use today, and we use quite often, is the rounding function, which basically, and if you guys remember this one, we already used this, right? We can put in, this has a hard-coded number, but if we had a value that was put in here from a column in a table, this is telling us to round that value to 2 decimal places, right? Why do we use that one really commonly? For money, right? Because money is rounded to 2 decimal places. So that's one that we'll play with a little bit today. Now, I'll be real frank. Some of these capabilities that are built in are pretty powerful. You can see they have things like cosine and tangent and logarithms and powers and radians and weird stuff like that. And I'm always reluctant, at least when I'm doing database work, to use high level functions like that inside of a database to produce reports. I'm more apt, by the way, to pull it out, put it into Excel and use Excel, or use Tableau or Power BI to do those things. Or if I'm coding solutions based on data from a database, I might be writing that code with Python. Ultimately, I might extract the data from a database and then use Python to do those calculations, right? However, right, and this is a big however, the fact that we have all these functions built in show you that you can actually do some very powerful mathematics inside of a database, and they have a whole bunch of date time ones as well. And then they have some other ones which we call advanced functions, and some of them are key to very particular activities. This is an intro level course though, so learning these more advanced features would come at a later time, right? So we're focusing on the basics for now. All right, I'm going to move now to these other commands, which are also pretty important for today's work. The first one is group by. So this will take us back to W3. And it basically is a interesting kind of statement because it allows us to basically, I'm not sure even what the best word is here. Maybe, I'll go back to that word they use, which is, okay, well, they're using it right here, aggregate. Or aggregate. So in other words, to collect things together. And you can see their definition says statement, the group by statement groups rows that have the same values into summary rows, like find the number of customers in each country. So in other words, we might not be looking at, for example, every person in the table, but I might group them by a secondary or a summary query that says, I just want all the customers from Mexico. And let's just take a look at their stuff, right? So we're going to group them by country so I can see all the Mexico stuff together. And then I might group them by Canada or England or something like that, right? And the data stays together. The other thing that it's important here is often when you're using that group by statement, and why these things are in the same chapter, you're often using it with these functions together. These are really common functions to use with the group by statement. So it makes a whole lot of sense to work them together. So giving you kind of a general lay of the land, the statements kind of look like this. So we do our regular select statements, whichever columns from whatever table, and then whatever conditions. But then as we're doing our output, we're grouping them by certain stuff. So for example, if I have, like, once again, a bunch of customers from Mexico, I'll get all those results together. And then I can order them by column name if that's even a consideration. Right. Demo data here again. And I want you to notice, and we're going to click through here, but the query here, we're looking for the count of how many customer IDs we have, and we want so the count of the customer IDs and a listing of the countries from the customers table, then they're going to be grouped by country. So let's take a look at what the output of that would look like. And notice the summary output, right? So I have a count now of 3 from Argentina and 2 from Austria, et cetera, et cetera, et cetera. So it went through, found the unique values in the country table, then did a count, and then grouped them together. So now we're kind of getting, I guess, more granular, specific information by using that group by statement. You can see the kind of the power of that, right? Like, how many people do we have in France? Okay, well, here you go. How many people do we have in Mexico? I guess 5, right? That's a good count. So that's an example of the group by, right? And I think very powerful, by the way. All right, here's another example. This one, we're doing basically the same thing, grouping once again by country, but we're ordering it by count, descending, which means the highest value one will be at the top, and then it will descend downward. So let's take a look at that and see why that might be useful, right? So the same basic query, but notice that now we're ordering it in descending order from the most to the least. This could be very helpful. It's like, where do we have the most customers? Ah, the USA. Let's focus our advertising there, that kind of thing, right? And these are metrics, and these are the kind of numbers and information that people that run companies want to look at. It's like, where do we get most of our overseas sales from? Okay, well, I would look here and go, well, Germany, France is good, Brazil's good, et cetera. Now, these are small numbers, for example, but the fact that we can not only qualify the information and group it, but also put it in an order that makes sense, that is meaningful to us. Right. So one of the reasons why that's very helpful. If you want, you can apply all this to tables that are joined, right? So that you can connect multiple tables together, run the same group by examples. Let's just do this one really quick, just so you can kind of get an example. So we're pulling from the shippers table, and we're pulling from the orders table, the count of the order IDs, and we're aliasing that. That's coming from the orders table. Then we're doing a left join from shippers ID to shipper ID on orders and shippers. And then we're going to group by shipper name. I know it's kind of a lot to wrap your head around, but basically what this is showing us is how many orders we're shipping through each one of these shippers. Now, we're not doing it in descending order. So if we don't, it just kind of finds, the shipper name and then just gives us an output. I could also do an order by in here if I wished, a number of orders. That might make sense. And then we could go descending on that one, have the highest one at the top. So interesting metrics for sure. All right, so that's a nice little example with that one. The other thing that we want to look at is the having statement, which comes next here on W3 School. So let's take a look at this. And this is, kind of an interesting thing, right? Because when we're using, and this is the catch with this, when we're using aggregate functions, we can't use the where keyword again, right? And we saw some examples of this, and those are actually what we call subqueries, where you have a query inside of a query. We use the having statement in spots where we can't necessarily use where to define the condition. What is the situation for that? We can't use it with aggregate functions. So let me just show you kind of what they mean by that, right? So if we're here and we're using the count function, and I want to do a select under a certain condition, normally I would say where here. But because I'm using the function, I have to use the having statement instead. So in this case, we're looking at a count of the customer IDs and the countries from the customer table. We're grouping by country, but we only want to see those that have a count of greater than 5. That's kind of the lay of the land on that one. So what does that look like when you run it? Kind of looks like that, right? Are all of these greater than 5? They sure are, right? But it's still pulling in the individual countries. It's still grouping them and giving us the qualified output, right? So very, very useful, by the way. If you want to add a little bit of sorting to them, you can just add an order by to it, right? So that I'm not going to demonstrate that one, but I think that's pretty self-explanatory. Once again, if you're joining tables together, so you're pulling a query across multiple tables, same stipulation applies. The count function criteria gets a little more complicated to express, but not really if you stop and think about it. Same basic type of approach here, folks. All right. I think that's just about all of my examples here, with the one last little tidbit. And I this is kind of interesting. I searched on W3 to find a write up about the roll up command, which the book talks about quite a bit. Um, and they didn't have anything in the MySQL section. They had it in the regular SQL section, and I didn't really want to delve into that area. So I pulled up this example from this tutorial site. This is the same one we used to do our install, if you guys remember. But they do talk about this command. And what I want to do is I want to kind of skip over some of the stuff we already know and kind of get to the bottom line of it, which is basically demonstrated down here at the end. But the whole kind of point of doing this, the roll up, is kind of a gentle way to say a summary. Is maybe a good way to think of it. So in other words, here we have something, we're selecting a product line, we're doing a sum, right, from a sales table, and then we're going to group by product line with roll up. So in other words, we have classic cars and motorcycles and planes, and these are our sales figures. And then notice here, the roll up in the product line creates a null because it can't really write back to the table. But what does it give us at the bottom? It gives us the total of all of these added together. So this really is the total of all those figures. That's what a roll up basically does. It basically is a way to summarize all the data relative to the kind of data that you're pulling. If you're doing sums of numbers, well, it's going to give you a grand total. If I'm summarizing the count, it's going to give me the grand total of all the counts. So if I was grouping stuff by country, but I still wanted to see what the total was, I can do that. That's what the roll up brings to the table. I'm going to leave it as simple as that because I really don't want to take it too much farther than that because it's not really applicable beyond our homework, but I just want to make sure you're introduced to the concept. Is everybody cool with the stuff that I just presented? Any questions so far? All right, thank you. All right. Next thing I'm going to do is I'm going to jump back over here and I'm going to pull down the slides for the chapter here. And I guess I'm going to run it right in the browser since it's loading up pretty nicely. Once again, there's lots of slides that the author provides. I think they're frankly overwhelming, and they're really more useful as a reference than necessarily latching onto every word that the author says in the book, right? And I don't know if you guys have figured that out yet or not, but I'll keep repeating that. The general objectives of the chapter are, in terms of applying this, is using, basically the grouping functions, which of course have to go with those aggregate functions that we were looking at, min, max, sum, count, and average, and then adding a little roll up to it. That's the general overview of what we're trying to do. All of these statements, by the way, the aggregate functions, we saw how those work. So like what we're selecting on the inside is relative to the object that we're selecting it from. So usually it'll be like a column name, that type of thing. So we have average, sum, min, max, count, and then count star, which is counts everything in the table. We've played with that one before. Here's an example of the count star, right? We played with that. And it just basically gives a summary without having to look at every row. And once again, great example. If you have 10,000 rows, do you want to look at all of them or scroll all the way to the bottom to get the column count? No, that's the why we do it. We can also do a bunch of stuff with that generic thing, so we can add it and we can make it look fancy. So you can do a summary query basically like this, where you can count everything. You can apply aliases to it, and you can come up really with just a single line output that shows you a combination of many of the things that we just looked at. So the count, notice in this one, we're going to play with this a little bit here, right? We're going to do this in one of our exercises where we have a function. The function that we're really doing is the average, right? And all I would normally need to do to get the invoice total average is just make that statement that I've just highlighted. But since it's money and I'm doing an average, I don't know if I do my division, if I'll land exactly on like hundredths of a penny or hundredths of a dollar, actually. right? So then I put that function inside the round function along with the number two to round it to 2 decimal places. So it is possible to put a function inside of a function if it makes sense. The rounding one is one that we often use that way, by the way. So we'll do a total or an average, and then we'll round it so it works for money. Right. So here, basically, we're looking at count, average, and sum as all part of the same query, and applying a condition to it so that basically, if it happens after this date in 2018, then we want to see, what is the average invoice amount? What's the total invoice amount, the number of invoices, and isn't that really helpful? Now, of course, if I took this number here, this really large number, divided it by 114, it should equal out to that. And that's one way you can double check it, by the way. Another complex query where we're looking at the total number of invoices. And in this case, we're looking at the biggest one and the smallest one. That's an interesting metric. A manager might want that information. Another one where we're just doing, notice that this is kind of an interesting one. We're doing the minimum and the maximum, right? So for example, if we're looking at just the minimum vendor, like who's the vendor that has the smallest, amount of purchases, right? And how many vendors do we have? And in this case, Abbey Office Furniture. But is it really pulling in the smallest purchaser? Is that what it's actually doing here? Or is it pulling in minimum? Is it pulling in the first one alphabetically? It's kind of an interesting thought, isn't it? Yeah, that's what it's doing. So you can apply max and min to strings and it will find the first alphabetical instance. Interesting, bizarre feature, but totally works, by the way. All right. Here they throw in the distinct keyword. And when we throw in that one, we haven't really talked about that too much, but basically the distinct keyword looks for a very, very particular vendor, right? That would be designated here, right? Once again, count, average, and sum rounded are all kind of applied. All right, then we kind of look at the general syntax once again of the group by and having clauses. We did this before, so I'm going to kind of skip over that pretty quickly. And this one kind of shows a little bit of a usage of it. So this is why I'm showing it. I think we have one exercise that sort of looks like this one. So notice that they're taking the vendor ID, they're taking the average invoice, rounding it to 2 decimal places, and then showing that as average invoice amount. From the invoices table, we're grouping by vendor, and then only if the average total invoice is greater than 2,000. And then we're setting an order as well. So you see like all the little syntax things that are happening here. Once again, the situation dictates the syntax. All right. So here they show a little bit of a thing, and notice what they say here. That includes a functionally dependent column. So what that means is we have to look at basically multiple pieces of information in order to really determine this. So if we're going to look at like the invoice amount relative to our particular vendor, we also have to look at the invoices, which are not necessarily part of this table. They're joined in from a different table. So we're dependent upon information from a different table to be able to pull it in. This is a more complex query, but kind of a good example. A lot of examples here that I'm just going to start to gloss over at this point because we're already beyond like the scope of what the homework does. But I just want to show you that you can do summary queries with joins, which we looked at before. The having statement instead of using where we're setting criteria, right? And this is where your query design kind of gets a little deeper, by the way. Another example with a having, and I know I'm going really quickly through these, but these do become kind of functionally irrelevant compared to what we're doing. And then notice this one where we're using a where clause, right? instead, right? Why? Because this one works relative to what we're doing, where in the previous one where we use where we're using having, it's really relative to what we're accomplishing in there. So for example, the where clause here works because we're not running a function on it, you see, right? Here, the having clause, we are running a function, so it's required that we have having as the criteria. So these are kind of weird ones to latch onto, but if you do it incorrectly, by the way, MySQL Workbench will highlight it and let you know. And then it's up to you to decipher the error message and convert it into what makes sense. Once again, a where statement, that works. No functions. A having statement, because we do have functions. See the difference, right? It's really very simplistic. All right, racing ahead here. So this is an example with rollup, right? So now take a look at the very bottom line there where it says group by vendor ID with rollup. So we have everything grouped. We're getting all the information that we're trying to get. And then we have one extra row at the bottom. Notice the null identifier in the vendor ID because we're doing summaries. We can't really summarize the IDs, but we can summarize the counts and we can summarize the totals.
Hey,
Right?
I
Those
read
make
that in the
sense.
book, and those are not the summaries.
What are they, George?
I don't know, but they're not. If you add up the column in invoice count, it doesn't add up to 114. I got confused.
Yeah, you know what? This is a snapshot of a partial output, and here's the right. So you're actually trying to take numbers and go, aha, these numbers add up to 114, and they don't. And that's because if you look here, there's a little scroll bar. So there's stuff above it that they're not showing. They're
Oh,
summarizing the output for our convenience, is what's happening.
oh,
Right.
yeah,
So
that really threw me off, so I gave up at that point, actually.
yeah. I think we have one exercise where we're going to use that anyhow. So um, we'll experiment with it and see what results we get in class. I think that's probably helpful. Um, this is another example of the with rollup, and once again, I didn't get a lot of documentation in W3 on this one, and there's issues with it when you start doing rollups and you have null values that you're dealing with. That's what these slides are kind of pointing out. Another thing, and we don't get into coding any of this in this chapter, so I'm going to gloss over it pretty quickly. But here we get into if statements, and we haven't talked about this yet. Python people, we are starting if statements tonight in that class, but we can also introduce some programming logic into the mix here. And just to make it as simple as I can in this class, a little confusing things, is an if statement is basically where we are grouping based on different pieces of information based upon criteria, right? So like if we can group by one thing, we will. Otherwise, we will group by the other if we can. And it doesn't always ring true. And I really don't want to go too deep into doing if statements here in this chapter because it's really kind of beyond our scope. But the book does talk about it fairly extensively. But it's not part of our homework, so I'm not going to focus too much on it. All right. This is as far as I'm taking the lecture pieces in this chapter. So I'm capping it there, folks. And then we are going to stop this recording. So the lecture material ends